start out by talking about the biomaterials of Axigard. And so this product line is made from porcine small intestine submucosa. And again, it's an extracellular matrix. And the real benefit of this material is its porosity. It has this very open and porous structure. And the advantage of that porous structure is that the patient's own cells can enter the material and they can start laying down new matrix, which then basically remodels the material. It becomes the patient's new tissue layer. And I want to just say the picture on the bottom is through the edge of the tube, and that's where we have that porosity that allows the cells to get in. When you're looking at the surface of the tube, the porosity it's not porous like the edges, and that's because we don't want scar tissue to be able to infiltrate into that tube. So it's important to remember when we talk about that porosity, we're really talking about from the product edge. And, you know, it is semi-translucent, which is a real benefit because the other products on the market, most of them are not translucent. And so it can be very difficult to ensure that the nerve ends are aligned within the conduit, which is something that you really want to do to ensure you don't have fascicular misalignment. So you've heard me say the word extracellular matrix many times throughout this presentation. And so what is an extracellular matrix? Well, an extracellular matrix is composed of the non-cellular components of organisms and tissues. So these are the collagens, the proteoglycans, the glycoproteins, and what they do is provide the structure and support to the cells in the area. And they vary structurally between species and by location in the body. But the really cool thing about extracellular matrices is they can be manufactured into various shapes and forms. And what extracellular matrices do is that, again, they provide that environment that's conducive to cellular infiltration, which then allows the patient's own cells to lay down the new matrix. And that basically remodels that material into a new tissue layer. So you can think of it as that extracellular matrix serving as a blueprint for new tissue. It tells the body where to lay down that new tissue. And in the case of the nerve, that new tissue is an epineurium-like tissue. And so this is what it actually looks like in the clinic. So this is a case that was provided by Dr. Bunke. And this was a case where he used an Axigard nerve wrap around a nerve. And about 6 months later, he had to go into the same area in order to do a tenolysis. And so since he was in the same area working, he took a look at what had happened to the Axigard material that he had implanted 6 months before. And you can see that it formed this nice tissue layer on the nerve, and that he was really very easily able to separate that tissue layer away from the nerve. It doesn't adhere to the nerve at all. It just forms a nice protective layer around that nerve. The top picture on the left is from the initial animal study that we did looking at the Axigard material around nerve. It was done in a rabbit model because rabbits are known to have a propensity for scarring and inflammation, especially in response to implants. And what we found was that at 6 months, the material had remodeled into this nice new tissue layer around the nerve. It didn't adhere to the nerve at all, and the nerve was able to freely glide within that material. The picture on the right is what this looks like in surgery. So again, this is another case where Dr. Evans had to go back into the same area where he had used Axigard, and you can see how it forms this new tissue layer around the nerve. And then finally, the bottom left picture is a neurogen tube, and you can see that it doesn't remodel at all. It just sort of, you can tell exactly where it is, and it just sort of maintains that tubular shape. So we do have some clinical studies that discuss the use of SIS in the clinic. One is from Jordan et al. And in that paper, 71 patients had an Axoguard nerve protector, and there were no cases of infection, persistent inflammation, or recurrent fibrosis. Now, they didn't really have outcomes on these patients, didn't really say whether or not they improved, but you know, with no recurrence of fibrosis or infection or inflammation, it's still an important paper to demonstrate that, you know, in the use of the clinic, we're not really seeing any sorts of you know, issues. And then the second paper here by Papatheodorou, in that paper, they actually looked at outcomes after use of Axoguard. And so these were in patients who had recurrent cubital tunnel syndrome, so patients with a known propensity to scar. And what they found is after use of the Axoguard nerve wrap, there were no complications, and the patients had significant improvements in pain, satisfaction, grip strength, and pinch strength. And 100% of the patients reported improvement.